Okay, in chapter 3, I just wanted to talk about a couple of quick concepts here. The concept of shape, and as it pertains to skewness of data, and the summary statistics for those types of data, mean and standard deviation, and the median and the IQR, and basically when they're appropriate. So shape is probably one of the most important things that we want to consider when we're thinking about quantitative data, and I got a couple of histograms here. In this case, I'm talking about the shape, in other words, the modality, or how many peaks my data has. Unimodal, uni means one. We can clearly see we have a single peak here. This was referred to as bimodal, and we can see that we have two separate peaks here, bi meaning two. And here's another distribution. It's referred to as a uniform distribution. Well, all the data isn't exactly the same height. All these different categories, all these different bins aren't exactly the same height. They're roughly the same height, and we can roughly refer to that as a uniform distribution. Now, the shape of the distribution, again, can dictate how or what would be useful for a summary. Now, if I saw some data that looked like this, and I was looking at my distribution, I would be saying to myself, it really looks like I have two distinct groups there. So to talk about the average or the median of that particular group may not be really very informative when I think about what's going on there. Again, I may have two separate groups, and I may want to split them apart. Let's take a closer look at these unimodal types of distributions here, and the concept of skewness. So I know skewness is somewhat of a tricky concept because it just seems like it's backwards. When we refer to something that is skewed to the right, we're referring to the tail of the data and the direction that that tail goes. That would be a skewed right distribution, and obviously over here we have the tail coming down to the left. That would be a skewed left distribution. Now, when we talk about those being skewed, what we're actually referring to is we're referring to the mean. So remember that the median is the 50-50 point to our data. That is the center if I were to order all of my data, physically count them out, and that median would have an equal number above and below. Now, the mean is the balancing point. And if I think about each value's magnitude, and think about it kind of like a seesaw, those that are really far above or really far below, while there may not be many of them, can certainly have a lot of leverage, okay? And that's what gets exhibited when we talk about the mean. Now, the mean uses everybody's value, including obviously the whole size that they are, so those big values have a large influence and small values have a large influence, even if there's not that many of them. We also see a very similar situation with the spread. We have the interquartile range, again, which is the middle 50%, really ignores those super high and super low values. The standard deviation is a typical distance from the mean that takes into account each and every value and how far away that is from the mean. So this can be skewed or kind of not really representative of our data if in fact there's a couple of really large or a few really small values. It can throw off our standard deviation. So what I want to look at is I want to take a look at my distribution. And if my distribution is really skewed, that I probably aren't going to use my mean and my standard deviation as a representation for the center and the spread of my data. The median and the IQR, again, since it's based on order, it's less impacted by skewed data, and it's probably a better representation. But I always want to make sure I start off by looking at a picture of my data, and that'll usually put me in the right direction.